Let's explore the OSI model from the top down. Application layer is the only layer that the users interact with through software such as browsers. The primary function of the application layer is to convert information into a form that can be understood by other computers on the network. The application layer uses protocols such as HTTP, FTP, POP, SMTP, DNS, P2P, and Telnet. The application layer vulnerabilities include DDoS attacks due to HTTP floods that target web and application servers, malicious SQL code inserted into database queries, cross-site scripting, which injects malicious code into exe scripts of applications, and parameter tampering between client and server. Application layer mitigation includes encryption and authentication protocols such as CAPTCHA, and web and application firewalls to shield applications from the internet. The presentation layer takes the data given to it by the application layer and prepares it for the rest of its journey. This layer handles decryption, encryption, translation, and conversion. The presentation layer uses several different protocols including SSL, HTTP, HTML, FTP, and Telnet, to name a few. The presentation layer is vulnerable to encryption attacks and encoding attacks where cybercriminals seek out flaws and weaknesses and cryptography techniques. Phishing schemes which trick users into providing personal credentials is also a very big issue in the presentation layer. And also SSL, TLS session sniffing using tools like Wireshark to capture network traffic for malicious intent. The best way to mitigate these issues is to secure encryption flaws by applying all security updates and patches on a regular basis. The session layer is where the session is actually created. This layer manages connections between ports on computers and handles data flow. In a sense, it controls how computers speak to each other. The session layer also checks to see if all the data has been received and manages the termination connections. The session layer uses a variety of different protocols including SOCKS, ZIP, SMPP, RTCP, NetBIOS, and ADSP, just to name a few. Cyber criminals can hijack the session and exploit the protocols to establish the session. A hacker can then monitor network traffic and intercept the session during login. A great way to keep the session layer safe is to use HTTPS protocols to ensure proper encryption. Also preventing cookie access from client-side scripts from setting the HTTP-only header. Regenerate a new session key after authentication, and restrict failed session attempts. The transport layer establishes a connection with a three-way handshake, which is a method used in a TCP/IP network to create a connection between a local host or client and a server. It puts data onto the network and assigns source and destination points. This is where the TCP port is stamped on the header. The transport layer uses protocols such as TCP, UDP, SCTP, DCCP, and TLS. The transport layer has several serious vulnerabilities such as TCP session sniffing, ARP spoofing, port sniffing, ICMP attacks, and DDoS attacks. In order to mitigate the transport layer, consider using TLS and keep separate from non-TLS content. Public key pinning increases the risk of attack if the website visitor is not using a web client that supports HPKP. Lastly, prevent sensitive data caching in the htaccess file. The network layer routes data through physical networks using an IP address, deciding which physical path the data will take. This layer actually places the data onto the network and ensures the data gets to the correct destination. The network layer uses protocols such as ICMP, ARP, DHCP, and RIP. The most apparent network vulnerabilities include packet sniffing, IP spoofing, routing protocol attacks, attack to the ICMP protocols, and DDoS attacks by overwhelming servers with data. In order to keep the network layer safe, it is recommended to ensure firewalls and VPNs are installed and up to date, set routers to filter IP addresses, and enable packet filtering. The data link layer establishes links between nodes and checks to see which router or switch it should go to. This layer only cares about what its next node is going to be by stamping the following headers. The MAC address gets stamped, the LLC header gets stamped, the IP header gets stamped, and the TCP header gets stamped. The data link layer uses the following protocols: Ethernet, Token Ring, FDDI, and PPP, just to name a few. The data link layer experiences the following vulnerabilities: IP spoofing, IP sniffing, broadcast storms, insecure virtual LANs and VLANs, and misconfigured NIC cards. The data link layer action for safety is to use encryption to heighten confidentiality. In addition, use intelligent Ethernet switches which connect a physical port to a specific MAC address. Lastly, the function of the physical layer is to transport data using mechanical, procedural, and electrical interfaces. The physical layer is responsible for transmission of binary data through a physical medium. It handles how data is physically encoded and decoded. This layer only deals with binary data. Some of the physical layer protocols are hubs, fiber optic, wireless, USB, Ethernet, and Bluetooth. The physical layer vulnerabilities include anything that threatens the electrical signal of the network, such as cut or damaged cables, or a natural disaster such as flooding. An attack can also be user-induced, such as man-in-the-middle or phishing emails. The following suggestions will help to keep your network safe. Install network monitoring tools. Ensure a clean and safe work environment. Prepare for incremental weather. Install firewalls and virus scanners, and provide staff training on internet safety.